Hello and welcome to this webinar, How to Power Optimize with Latest Features in the nRF9160 System in Package. This is a webinar, a part of the Mobile World Congress Experience 2021. So the agenda for today is some practicalities at the beginning, introduction of the host, and then nRF9160 System in Package overview, going to go through the revision 2 updates. And then a little bit about cellular network complexities, how our modem makes it easy, and how it compares to some other solutions. And then we're going to look into how you can optimize for low power and using the new features, for example, in the modem firmware 130, that you should consider in your design to decrease your power consumption even more. Then some real-time testing with the Power Profiler Kit 2. And then at the end, we're going to look at the further help and technical support. Then program for the rest of the Mobile World Congress 2021, and then a Q&A session. So just some practicalities. The duration of this webinar will be around 45 minutes plus a Q&A session. So questions are encouraged throughout this webinar. Please type your questions in the top right sidebar. All questions are, of course, anonymous, so try to keep them relevant to the topic as well. We will answer the questions towards the end. And the chat, however, is not anonymous and should therefore not be used for questions. If you have any questions after this webinar is over, you can go to DevZone, our technical support portal, and you get your answers there. And of course, a recording of the webinar will be available together with these presentation slides at webinars.nordicsemi.com. So a little bit about myself. My name is Martin Lesund. I'm a technical marketing manager for Cellular IoT. I work at Nordic Semiconductor. And I have a Master of Science degree in electronics from NTNU in Trondheim. And my master thesis was about ultra-low power serial communication for Internet of Things. I joined Nordic in 2017 and it's based in Trondheim, Norway. Previously, I have experience in the tech support group, around 3 years, and the focus was then on cellular IoT and nRF9160. I have a dog, a fiance, and I'm moving to my house this fall. So first time house owners, that will be exciting. I am a tech geek, I love the outdoors, and I also like biking a lot. So now over to the fun stuff, nRF9160. So if you don't know, the nRF9160 system in package is based on our Nordic dual-core system on chip. So we have a ARM Cortex-M33 microcontroller for the application, and a multiband LTM and NB-IoT modem with GPS support. It's a small form factor. You have a 16 by 10 mm by 1 mm. It includes all the important stuff with the power management IC, and the RF front-end module, and the passives and crystals inside. So it is also ultra-low power. We have our average for 18 microamps at 81.92 seconds in the EDRX intervals. The power saving mode floor current is around 2.7 microamps. And this device is multiband support for global coverage and is also a pre-certified system in package. So it's important to note here that we have a separate application area and a separate modem area. So you can have your own application with your dedicated flash and RAM on the microcontroller area. This is the revision 2, and we can see that we have made some improvements on the 9160 with different key parameters. So you improve the CPU running core mark by 24%, PSM floor current is improved by 33%, and the average EDRX intervals in 10 minutes is improved by 33% and 18% in LTM and NB-IoT respectively. So if you have a revision 1, you can quickly change to revision 2 by just changing an external cap. Over to the LT connection modes. So we have 3 modes the modem can be in, either RC connected, RRC idle, or power saving mode. And in RC connected mode, you transfer your user data. You have a high power consumption because you need to stay synchronized with the network, and that needs a lot of power. The other mode is the idle mode, and there you can listen to the network if it has some data to send to you, and then you can also sleep for shorter intervals to save power. And also you have this eDRX, extended DRX opportunity to extend your intervals even more to save more power. So in this mode you have shorter downlink latency. Last but not least, we have this power saving mode. You can sleep for longer intervals to save even more power. So this means that the device will be unreachable for a network. However, you can wake up whenever you want. So you have a longer downlink latency here. And some details about these modes. So the RC connected mode and the RC idle mode is the ones that we are going to look at now. We have sleep in eDRX intervals to save power. So we have something called eDRX in both the connected mode and idle mode, but when we usually talk about eDRX, it's actually the iDRX, which is in the idle mode, because that has the best effect to low power consumption. One thing to note that we support all the timers. There are some modems out in the field that does not support all the timers, but we have made sure that Nordic nRF9160 support all of them. And this means that you can have a device that can wake up at any time to send data, but for the rest of the time it can stay and listen through these paging intervals. And the network can store data for the device if it has that supported, or else you should have the server buffer up the data. The device listens for data at the end of each DRX interval, and the longer the DRX intervals results in longer download latency, but also lower power. For the next mode, we have power saving mode. So this is a mode you can jump to either directly from RC connected mode or from RC idle mode. This is the mode you will use when you're going to save a lot of power and sleep for a lot. You can sleep from 10 minutes to up to 413 days in theory. However, some networks require you to wake up to send this tracking area update to update the network where your device is. So this interval can be different from network to network, so that is something you should be aware of. The device can of course wake up at any time to send data, but it cannot be reached from the network when you are in PSM. After the end of the PSM interval, you do a connection and you switch back to RC connected mode and send this tracking area update and or your data that you want to send to the cloud. So of course, longer PSM intervals results in longer downlink latency, but also a much lower average power consumption. So this mode has a lower floor current compared to the iDRX intervals in RC idle mode. So this is just some things that you should be aware of with the cellular IoT development. There are some network complexities. So we advise you not to trust and rely on a few spec points when you compare some cellular modems, for example, because cellular is complex and we have many different parameters that affects power consumption. We have, just to name a few, we have the RC connected mode, CDRX intervals, CDRX inactivity timer, idle mode. Yeah, we have a lot of things that affect, of course, the signal conditioning, the bands you're on, and of course the repetitions you can get if you have a bad connection. So just an example here is that most modules has shown that they have a low PSM floor current, and that is something that they market and have in a specification. But we also see that most of these are actually more like a system off current, which means that they do not have a RAM retention, and also sometimes doesn't even have GPIO retention. So this means that when the module needs to wake up or get out of PSM, it actually needs to renegotiate with a network for each wake up. Yeah, this is taking a lot of power consumption. And also, they often doesn't take into account the SIM current, and the external MCU current are also usually not included in these numbers. So compared to nRF9160, for example, we are always attached to the network even if we are in the PSM mode. So the network knows that we are sleeping, and when you wake up from PSM mode, you do not need to renegotiate with the network because the network already knows of our device. How does the nRF9160 make it easy for the customers and the developers? We have a very intelligent modem algorithms, which are always improving and gets optimized with further updates. And the modem handles all the complex parts automatically. So you don't need to think about most of the things. You can request different parameters for the modem and it will take care of the rest, for example. And like I mentioned, we have modem firmware updates, releases with optimizations and improvements, of course bug fixes, and also new features for major modem firmware updates. So we recently had an update for the 130 release, and that included a lot of major updates. Also, we have a full open source and scalable software development kit, the nRF Connect SDK, which you can have on your application core, where we already have many samples, the drivers and libraries for the developers to use as reference or into their designs. Like I said, some other modules have shown that they have a very low floor current. This is a module that has the 1.8 microamps as a PSM floor current in their spec sheet. And in this graph here, we are going to compare the nRF9160 PSM floor current with this module X. This graph is actually comparing the average current generated from a system wake up to data transmission of the module X PSM, and also we're going to showcase the nRF9160 PSM. Here is the nRF9160 power saving mode average compared to the module X. So we can actually see that we have a power saving mode floor current around 2.7. However, we are still much lower than the module X, even if it has a lower PSM floor current. The reason for this is that this module X has a much heavier renegotiation each time it wakes up from PSM mode to send data. If we also look into when the nRF9160 turns off its modem completely, we can see that it's even more efficient when we are sleeping for even a longer time. So around 63 hours in this example, it's more efficient than even the PSM mode in the nRF9160. In nRF9160 off mode, you need to do this network attach each time you wake up. However, we are including the RAM retention here. So the module X does not have an application processor. So in this graph here, we have added on an external MCU sleep for around 500 nanoamperes for the module X. And also the module X excludes the SIM currents. That is kind of the point I'm trying to make here, that PSM floor currents does not give you the whole picture of the average total current consumption that you will have into your device. And this is because the nRF9160 has been built from the ground up to be low power and also improve our device, either hardware or in the software. So for example, the revision 2 improved a lot of power consumption, as well as modem firmware 1230, for example, improved in a lot of different scenarios. We're going to look closer into that later on here. Now we're going to look into how you can actually optimize for low power. So what is drawing the most current in a cellular device, it is typically when the radio is on and when you send and receive data. That is where you use most power, and that is where you want to kind of reduce the use time of the radio as much as possible to save the most power. And then you typically have these EDRX intervals that you can extend and also utilize the power saving mode. This is different methods to increase the intervals when you are going to send and receive data, for example. And these are known techniques and are especially optimized on the nRF9160 system in package. And also another thing that you should consider in your application is to send information and not all the data. For example, on the right-hand side here, we just have an example on sending data, receiving data, and processing data on the microcontroller unit. So if you have a device that has an accelerometer, so instead of sending all this accelerometer data when the device is moving and sending this over the cellular network, you could instead process this data and send data only when the device, for example, is fallen off a ledge or is upside down or whatever your application is. So instead of using 60 milliamps, you can use 3 milliamps to process this data and send a short information over the cellular network. So that's why we have this sophisticated MCU on board, the M33, to actually process this data. And also, other ways to optimize for low power is these new features introduced in the modem firmware 130. And the first one is when you do your first search, you need to connect to a network. And we have introduced two new features that will help you very much in this scenario. It is the first LT search optimization and the modem domain events feature. We're going to look closer into this very soon now. And also, when you send data, you need to do that in good conditions, are another technique you can use. And for that, we have this new feature, pre-evaluation of a connection. This is something that you just do a quick measurement of the network, and if you have good conditions, you can send data. And also, you can have another way to save power, is this avoid the RC inactivity timer by utilizing this AS Access Stratum Release Assistant feature that we have introduced in this new modem firmware. That is just some techniques that we're going to look closer into, but I would also like to mention some other things that we improved in the modem firmware 130. We improved the search algorithm for better efficiency, and also we improved the cell reselection and cell selection when you're going to connect to a cell to connect to the network. And also we have improved the paging reception. So the modem will stop monitoring paging during occasions after decoding just the first number of repetitions on the paging channel. And also just a mention of we have support for NID, non-IP data delivery, which basically means that you avoid the IP overhead you can have when sending data over the NB-IoT network. That means that you can shorten the time where you need to have the radio on. And also we have the support for NB2 features, such as higher throughput. So instead of having a throughput of 62 kilobits per second in uplink, you have now support for 169 kilobits per second. Same goes for downlink. You go from 27 kilobits per second to 126 kilobits per second. Over to the first feature that I want to highlight. It's this first LT search optimization. So this is typically something that you could use when you're launching your device out in the field and you want to speed up the network selection. So either when you're the first time deploying or moving to a new area where the device has been shut off for a while. And this is something that the modem will go through. It will go through a list that you have made. You have stored, for example, the mobile country code, the bands that are important for this area that you're going to launch, And also you can add in the radio frequency channel and also your preferred technology, either LTM and NB-IoT. And this can be done through an AT command. This will speed up your first LT search optimization. And if it doesn't find a network after this list, it will go over to a normal search, which is still a kind of an optimized way of searching for a network. So if you have a device that is very constrained device and needs to have low power, you can also set in a very helpful domain event when the device is finished with its light search, for example. So it will first do a light search and then a heavy search, you could say, when looking for networks. To avoid going to this heavy search, you can subscribe to an event, and when you get this light search event, you know that the modem has done its most intelligent searches and haven't found a network yet. You can shut down the modem and wait for better conditions, or if the device is moving, for example. And then you would save current. And then we have this pre-evaluation of a connection. This is very important before you send your data, and you want to know how much power consumption you're going to use. So this is a clever way that we have solved this issue. So you can evaluate the power consumption before connecting and sending data. And how it does this? It's the modem does a very short measurement and analyze the radio environment on a downlink on a cell. This doesn't use a lot of current. From this data, the modem will return an estimated category for you, either excellent, good, normal, poor, or bad quality. So if you get an excellent quality, you know, okay, I can send my data and I wouldn't use a lot of power consumption. If I get poor estimate from my modem, I know that I most likely will get some repetitions, bad signal quality. My radio maybe needs to stay on for a longer period of time, and also I could get some repetitions. And also the modem will provide you the raw parameters if you want to do your estimations yourself, or you want to know more about different parameters. And then I talked about this avoidance of the RC inactivity timer. And this is a feature that we have had in the NBA IoT technology for a while. And in modem firmware 130, we introduced this support for the LTM network. And this RC inactivity timer is something that the network sets this timer, which you would need to have the radio on after each time you have sent or received something on the network. And this timer can have a huge impact on your overall power consumption because this is very different from network to network. Some networks have 4 seconds and some networks can have up to 15 seconds. And a worst case scenario, I've seen even 60 seconds. So that means for each time you send your device, you need to have your radio on just listening to the network if it has some more things to send to you. However, when you know you are not going to receive or send some new data right after sending some data, you can request the network with this AT command here to release you from this inactivity timer. And that means that the network can approve this if it has support for it, and you can go directly into the next mode, and you will get this RC release much faster than before. Just an example of utilizing this feature here. If you send a data, a UDP packet around 1K of bytes each 30 minutes, and the rest of the time you stay in power saving mode. When you're using this Access Stratum Release Assistant indication, we can see a 50% improvement. That means double your battery life just by enabling a feature. In this specific example. This is something that you should be aware of and look for if your network has support for this feature here. And this is a 3GPP Release 14 feature. So on the left-hand side here, we have done some estimates using our online power profiler for a scenario sending this data with the RC inactivity timer of 11 seconds. So we can see that the average total current is 72.5 microamps. And when using this Access Stratum release assistant indication feature, we can see that the total average current dropped down to 37 microamps. That means you have a battery of 2 years or 4 years just by enabling this feature. So this is a very nice feature, something that you should use if you can. And we have typically asset tracking applications that would need low power. And for this, we have support for cellular positioning. So this is a fast and ultra low power way of doing location. You will save power when accuracy is not needed. And this also works indoors. And the way we do this is through single and or multi-cell measurement support. And for modem firmware 130, we introduced this neighboring cell measurements that you can use for LT location services. And also our integrated GPS is great for when you're going to do accurate tracking. And you can have an accuracy down to 3 meters. And we also have support for assisted GPS and predicted GPS. Assisted GPS is when you download the ephemeris and almanac data directly from the LTE network and uses this data to find your satellites much faster. So you can increase your time to first fix from, for example, 1 minute to 5 seconds, because it takes a long time to download data through satellites. And instead of doing this, just do it directly through the LTM network or NB-IoT network and get the GPS fix much faster. And also we have this predicted GPS support, which means that you can have this data saved for a longer period of time and get a time to first fix much faster when you are going to look for the GPS. And we have continuous interval and single show mode for the GPS. And also in our modem firmware 130, we did a lot of improvements on the GPS side as well to use lower current. And here is just an example on how you can utilize both technologies. So if you have an asset tracker or a device that's moving into a town, you can use cellular positioning to save a lot of current when the device is on the way to a town, for example. And you can see that accuracy is not important and it's moving a bit based on your cell positioning, etc. And you can see that it's still going down this road and going into the town. And when you get into the town, you can then switch over to the GPS in your application. And you can get a very accurate tracking. So it's no use to have this GPS on all the time when you're just driving down the road, for example. That is just, using a lot of power that's probably not needed in your application. And to learn more about this, I would strongly suggest to sign up for the How Cloud Helps Your IoT Devices to get location data, this webinar that we're holding this week. So I talked a lot about the modem firmware and how we have improved in different scenarios and different features that you can use to improve your application's power consumption even more. But this is the nRF Connect SDK. That's the SDK that you have on the application processor. And we support all the major protocols. We support MQTT, CoAP, lightweight machine-to-machine, and also HTTPS, for example. This is native in nRF Connect SDK. It's open source and free of charge. It's hosted on GitHub. You have support for flexible sockets. You can connect to, for example, multiple clouds and services. And we also have support for robust and flexible firmware over-the-air updates. So if you want to upgrade your application or your modem firmware, you can do that. And we have a real-time operating system for a modular approach. We have support for the SiP RTOS. And we have, of course, full application and cloud examples in nRF Connect SDK. These connectivity protocols are seamlessly integrated with our modem through this modem library. So the latest modem library is 121, which was released in nRF Connect 160. So that means we both deliver you the modem firmware and the SDK. That means that we own the entire solution. That means we can give you very simple support, and you only need to ask us of anything that you have any issues or questions on. We will help you out because we know what's inside our devices. And that means that you can focus on your own application on top of this SDK. And so on the right hand side is kind of a block diagram of the different things that we have in the nRF Connect SDK, which is on the ARM Cortex M33 microcontroller core, and the modem part, which we have the modem firmware. So you'd only need to focus on the top part here to have your main application and your connectivity application, depending on what you're going to run on your device. And now we're kind of looking into how you can do your optimization of power consumption. So we have made the online power profiler for cellular IoT. This is a tool that's hosted on Nordic Semiconductor DevZone page. So this is an extensive tool with a lot of parameters that you can set in this tool here, this calculator, which will do estimates based on these parameters. So you can estimate your power consumption of specific scenarios. You can use this information to do some quick analysis and estimations for an example application that you're planning. This means it's very easy to use. We also have an extensive user guide. You don't need an expensive LTE call box to control and set network parameters. You can easily and quickly reconfigure, test, and learn quickly on how the LTE network works through this tool, for example. And you can see which parameter actually has the biggest effect on power consumption and why. And also you can export the settings that you gather from this tool to the nRF Connect SDK project. So we have our own sample in this SDK that you can export the settings to. And then you can, for example, compare these results with the Power Profiler toolkit. So you can actually estimate your current, and then you could actually measure the current on a real network and see how it compares. So this is just a demonstration of the online Power Profiler for LTE. So here it is. You can set the RRC idle mode, but here we have a preset list. So you can select a network. We have different networks you can select from. And you can also set the active time, how long you're going to stay in RRC idle mode, for example. And also you can set the EDRX interval here. You can switch between all the different timers. And also you can set up if you're going to download any data or upload data. And this is UDP based. And here we just select 10 bytes and also the transfer interval. And here you see the different modes. The RC connected mode, the RC idle mode, and power saving mode in different colors. So this is simulated in real time when you put in these parameters here. And you can go into each event and look how much current it's going to use, how much time, how much charge the estimate would do. And when you are finished, you can see that the total average current is calculated on the top there. So it's important to note that this is just estimates, but it gives a good picture on how much current consumption your device could use. And then we have the Power Profiler Kit 2, which is a first of its kind tool for cellular developers. So you may know that we had this Power Profiler Kit 1, but this one is a much improved hardware, which now supports cellular devices as well, our nRF9160. You have a current range of 200 nanoamperes to 1 ampere, and also you have a resolution varying between 100 nanoamperes and 1 milliampere. It's perfect to track and measure power consumption on all Nordic devices. It's simple, accurate, and very powerful. And it's very easy to estimate battery life of your device through this device here. And you can easily spot and debug unwanted current drains in your application when running this. You get the current measurements in real time when running your device. And it is also very nice to compare your results with the online Power Profiler tool. Yeah, it's simple and cost efficient as well. So it's very small, you can put it in your pocket and travel around and always bring it with you. So here is the Power Profiler kit in the demonstration here, and we are running the Power Profiler application on nRF Connect for desktop. So here just start capturing the data and we enable the power output. So here we are running the UDP sample that we have in the nRF Connect SDK. And we can see that the nRF9160 first searches the network, connects to the network, and then it sends around, I think it's 1000 bytes. And then it goes over to this RC idle mode and then power saving mode. So here we do the connection to the network. First it searches for a network and then it connects around here, and then you send the data, and when you are finished sending the data, you are going into this RC inactivity timer that I talked about. And here is the spike for the RC release, which is coming from the network, and that means that the network then will release the device from the network, and you can go over to the mode that you have configured. And in this sample I configured it to go directly to idle mode and stay in idle mode for a couple of seconds and then over to PSM mode afterwards. And further on here we're going to look into how you can check out the different scenarios. So here we can mark up something that you want to look closer into, and you can look into the average current of the PSM mode, and by just marking it you get up PSM current for 2.7 microamps in average. And of course you can zoom in very much and look into each event in high details. So here is a CDRX event, for example. So this is a very useful tool, and I encourage you to use this when you're optimizing for low power consumption. This is actually a measurement that I did today for a UDP sample, and I stayed in RC idle mode for 2 minutes, and then I went into power saving mode. So, and this example here is actually running the modem firmware 123. So now we're going to just look into how much power we actually optimized in RC idle mode, for example, by just upgrading your modem firmware. So let's just see the average current here. So the average current in RC idle mode with the EDRX set to 0.64 seconds. It's a very high active interval. So this is quite a high number, 1.8 milliamperes, when using modem firmware 123. So for the same scenario, but with using the latest modem firmware, you can actually see the improvements by zooming zooming out here by capturing everything here. So yeah, so instead of 1.8 milliamperes, we now have 1.05 milliamperes in average in the RC idle mode. And this is just by updating your modem firmware. So when we say that we have improved and optimized our modem in every scenario, you can actually test this yourself and also compare and see that, yeah, we have actually improved in many scenarios. And in RC idle mode, we can see that I can show you in the events, for example. So if you look into a IDRX event here, I zoom in and we can see here. Okay, so we use around 11 milliamperes per IDRX on the modem firmware 130 in this network, in this scenario. And if we look into a picture that I captured here, we can see the same for the modem firmware 130 here, like I show here. And also you can see on the top page here, the modem firmware 123. And you see that we have shortened the event here, and also this has been removed. And the reason for this is that we have been able to figure out what is needed and what is not based on this paging reception decoding that I talked about earlier is one of the reasons, and we also have some other stuff that we have improved. And that means you can you save a lot of power consumption by just updating your modem firmware. Over to the slides here. If you need any more information or help, we encourage you to look into our webinars. We have made a lot of webinars in the last couple of months and also years. All the information that you need in different scenarios. And for example, if you want to look more into cellular IoT on how you can measure power consumption, etc., we have a lot of webinars around this as well. And also we have the Nordic Developer Zone for questions, and you get in touch with our tech support center. And we also have Nordic GitHub with a lot of repositories with samples that you could check out. The next thing that you should be aware of is the rest of the Mobile World Congress 2021. So today we have had this how to power optimize with the latest features in the nRF9160 webinar. And tomorrow we are hosting the Expand Cellular IoT coverage with iBasis connectivity. So this is a partner webinar. And then the day after that, it's this cloud webinar, how cloud helps your IoT devices to get location data. And the day after that, we have exciting new features in nRF Connect SDK version 160. So I highly encourage you to check out these webinars. They will also be available on demand if you cannot catch them live on the dates. We encourage you to sign up for more webinars on our webinars.nordicsemi.com. If you have any questions, get tech support and join our community on DevZone. And also you can find more information about all of our products and services on nordicsemi.com. Yeah, so now let's have a Q&A session. So I will answer your questions. Good. So there's been many good questions from the audience. Thank you for that. So the first one is from a person that has designed his own custom board with an nRF9160, but is seeing a power consumption of 6 microamperes in power saving mode. But when he compares with the DK, he sees a 2.7 as expected. So he asks, what's wrong on my board? So I suggest you make a DevZone case and you share your schematics and layout files, and we at Nordic will review it and look if there's some issues on your custom board. And there's another question here. When is the revision 2 of the nRF9160 system in package available? So it's already available. We released it actually last year. So you can actually order it now and use it into your designs. Another question, do you have any recommendation for the best way to get started with the development on the nRF9160? So I would highly encourage you to get a development kit. Then you can just download the toolchain manager and you get the whole nRF Connect SDK environment. And you can get started developing with that, following our tutorials, our webinars, and you should get very much information there to get you going. And if you have any questions, we have a dev zone open 24/7 for questions. So, and another question here. One person has measured the nRF9160 DK with the power saving mode, and he says that he gets 700 microamps instead of 2.7. So this is typically the UART that is still enabled. So if you get around 700 microamps in power saving mode, this usually means that the UART is still on. So you can turn this off in the project conf file by just setting the config _serial equals n. Then you will disable this. And there's some question about the Access Stratum Release Assistant indication feature. So what about skipping RC inactivity timer in LTM? So yeah, that's the new feature that we introduced in modem firmware 130. We had support for it on NB-IoT. Now we have support for it on LTM. And it is dependent on the network to have support for this. So the network needs to have this supported to be able to skip the RC inactivity timer. So either you can test this or get in contact with your network carrier. And there is a question about, can you give a quick overview how these features goes hand in hand with the NCS or nRF Connect SDK and the modem firmware? Example, what happens to the microcontroller unit when you enter the power saving mode? So that's the nice thing with the Zephyr RTOS and our nRF Connect SDK. When the MCU does not have anything to do, it will automatically go into this idle mode. So when you go into PSM and the CPU doesn't have any work to do, it will automatically go into this idle mode, and you will see around 2.7 microamps in power saving mode floor current. So this is included for the whole nRF9160 system package in whole. So it's both the application processor and the modem you see here. And there's another question: do you get the cell ID or just physical cell ID for neighboring cells AT command? So we have this new neighboring cell measurements AT command support in modem firmware 130, and you actually get both information out of the neighboring cell there. So you get the cell ID and also the physical cell. Could you give some more information about the predicted GPS feature? I didn't quite get it. So the predicted GPS feature is very nice for applications that drops out, turns off the GPS and turns it off and on quite often. And this predicted GPS actually stores the ephemeris and almanac data and the estimated ephemeris data for a longer period of time, which means that when you turn on the GPS already knows kind of where the satellites are based on these predictions, and then you can get a much faster time to first fix. So this can be stored up to 2 weeks, and the ephemeris data can be stored up to 4 hours, I think, and then you need to get new data from the cloud. Do nRF9160 support IPv6? Yes, the modem supports IPv6 and IPv4. And there's a question here: does nRF Connect SDK 160 is that compatible with the Thingy 91 hardware revision 10X? Yes, so it should be possible to run the nRF Connect SDK on that revision. I don't see any issues with that, but if you have any issues, just send us on a DevZone ticket and we will help you out with that. When will the revision 2 chip be available in the development kit? So that is actually already available. So if you look for the version number 100 on the development kit, that means that you have the revision 2 of the nRF9160 system in package on board. So here's another question. Is it necessary to use the version of the modem firmware certified by the network operated as listed in the in our matrix with the operator certification? So right now, here's an example. Is it possible to use the modem firmware 130 in Deutsche Telekom network, for example? So right now you can see on the matrix that we have support for 1 to 3 on the Deutsche Telekom network, but you should be able to use the 130 as well for development and testing, and the 130 will of course be certified onto the networks that we have listed in this matrix there. It's an ongoing role that we are doing now. So another question here, does the non-IP data delivery mode add up power consumption or consume less power consumption? So that's really the thing with this feature here. This is a feature for NB-IoT, where you skip the IP overhead, which is quite high sometimes, especially for NB-IoT. You would need to have your radio on for a longer period of time because you have lower throughput. So if you use NID, you can skip the IP overhead and only send your data, which means you can have your radio on for a shorter amount of time, which means you will consume less power. Then again, the network needs to support this feature. Does the country data AT command use MCC for the SIM card from the first network search it finds? This could be useful for roaming SIM cards. So yeah, this AT command for the first LT search can use MCC from the SIM card, and you can also use different other parameters as well. So it's quite flexible. So I recommend you to just check in the AT command reference manual for more information. Is nRF Connect SDK 160 released? Yes, so we released the nRF Connect SDK 160 this Friday. So you can download that now and test that out. Does modem firmware version 130 backward compatible with the software designed with older modem firmwares? So the thing with the modem firmware 130, it enables a lot of new features. So these new features would not be available for software that's designed on an older nRF Connect SDK version, because many of these features are kind of enabled in the modem library, which comes in a later version of the nRF Connect SDK. However, some things may be compatible, but we recommend that you use the latest nRF Connect SDK with the modem firmware 130 for the best compatibility. And also, if you're going to certify some specific carriers that require you to use the lightweight machine-to-machine carrier library, then you need some specific version of the 130 and nRF Connect SDK. Do you accomplish a cellular positioning indoors by triangulation? So the neighboring cell measurement feature that we introduced in modem firmware 130 actually can give you position indoors because it uses the nearby cells. So the more cells you have nearby your device, the more accurate your positioning will be. So we are talking about 100 meters, depending on how many cells is around your device here. So you can still get location indoors, yes. You do not need GPS for that. And there's a question here. We have been working with the Thingy 91 prototyping platform. It is really great. Do you have any plan to release anything new in the same line? So this is typically a roadmap question, so I encourage you to ask your local regional sales manager about roadmap questions. And if you don't know who that is in your area, just send a question on DevZone and we will help you out. Yeah, and will you be offering Assist Now offline services for faster GPS fix? I think this Assist Now is something that another module maker has called what we have called assisted GPS. So it would be the same thing, if I'm not mistaken. If you have more questions about this, just go on DevZone and we will help you out with that. Yeah, that was all the questions. Thank you very much for joining this webinar, and I encourage you to check out our plan for the rest of the week, and please sign up for those if you are interested. Thank you very much.